So in this problem, let us see how to draw the projections of a square prism when it is inclined to both horizontal and vertical planes. Okay, inclined to both the planes, and the problem can be solved in 3 stages. Okay, now let's look at the content. The square prism base 40 mm and the height of the prism is 65 mm, has its axis inclined to 45 degrees. Axis is inclined to 45 degrees to the HP and has an edge of its base on the HP and inclined at 30 degrees to the vertical plane. Draw the projections of the solids. Okay, now so these are the various conditions we should understand, we should identify from the questions. So where these conditions are going to be implemented various stages of the problem. So first thing you need to check whether the problem is resting on the horizontal plane or vertical plane. If it is resting on the horizontal plane means we assume it is resting on horizontal plane. In such a way we can see the true shape from the top view. Okay. Now the second thing we need to understand whether the solid is resting on one of its edge or one of its corner, we should know. And third, what is the axis inclination? Axis inclination with the horizontal plane or vertical plane. The axis inclination is going to be implemented in the second stage, and the edge inclination is going to be the represented or implemented in the third stage as well as second stage. Now these two parameters are going to be implemented in the first stage, that is we need to identify whether the solid is resting on the horizontal plane or vertical plane and whether it is resting on the edge or corner. So from this I can understand the square prism base 40 mm and height 65 mm has its axis inclined at 45 degrees to the HP and has edge of its base on the HP. So it is resting on HP on one of its edge. It is resting on HP on one of its edge. So for timing we are going to assume in the second stage axis inclination is there mentioned with the HP, and they mentioned that the solid is on the horizontal plane. So in the first assumption we are going to assume that the solid is resting on the horizontal plane just like this. Now let us say this is the prism, square prism, where the base corners are A, B, C, D and the top corners are 1, 2, 3, 4, and it is resting on its base corners A, B, C, D. Okay, so in such cases you can see the base shape, the square shape from the top view. So whatever the solid problem, we are going to start the problem by drawing the one of the base of the solid. Okay, whether it is pentagonal pyramid or hexagonal pyramid or cone or cylinder, whatever the base shape, that particular base shape is going to use to start the problem. Here it is square. And what is the dimensions of the square? 40 mm each side. I am going to draw the square with 40 mm sides. And perpendicular to this one. So the base corners are A, B, C, D. Let me mark them A, B, C, D. But when you see from the top corners 1, 2, 3, 4 also coincides with the A, B, C, D. If you see from the top, the corner 2 and the corner B are going to coincide. The corner 3 and corner C are going to coincide. So let us say this is 1, this is 2, this is 3, this is 4. Where 1, 2, 3, 4 are related to the top corners and A, B, C, D are going to be related to the bottom corners. Let us also identify the location of the center. Means I want to know axis center. At this point we have O1 as well as O2. O1 is the bottom base center and O2 is the top base center. So O1 is here and O2 is here. Okay. So as the base shape is over and the alternate view is going to be a rectangle. Okay. Whether it is a prism or cylinder, if one of the view is it's a base shape and the alternate view is going to be rectangle. For pyramids as well as cones, one of the view is it's a base shape, then the alternate view is going to be a triangle. Here it is going to be rectangle. I have to draw as a front view where the height of the rectangle is equal to height of the prism. What is the height of the prism? 65 mm, and width of the rectangle is equal to width of the top view, whatever I have drawn initially. So with this width, I am going to extend the lines, and the height of this particular prism in the problem is 65 mm. We have to draw line with 65 mm. So let us also represent the axis line. The base center is O1, the top center is O2. And let us also mark each and every corner in the front view. All lowercase alphabets comes at the base, and 1, 2, 3 will comes at the top. Let us say this is A dash, comma, B dash, and this is C dash, comma, D dash. This point is 3 dash, comma, 4 dash, and this point is 1 dash, comma, 2 dash. In the second stage, we have to implement the axis inclination. Its axis inclination is how much? Axis is inclined to HP at an angle of 45 degree. So in the second stage, horizontal plane conditions, whatever the horizontal plane conditions, I'm going to execute only in the front view. Horizontal plane conditions are going to be implemented in the front view. So I have to draw the same front view once again in such a way the axis of the front view I is going to be 45 degrees with the HP. And you need to understand one thing. So when there is an axis line, then there is a base. The angle made by the axis line is theta. Angle made by the baseline is, let us say, pi. The sum is always 90 degree. Sum is always 90 degree. Here the what is the theta? Theta is going to be 45 degrees with the HP. So 45 plus pi is equal to 90, where pi is equal to 45 degree. Means I am going to draw the baseline with an inclination of 45 degree. It has center, 45 as center. I am going to draw the line. So how much it is from here to here? 40 mm. With the same 40 mm, I'm going to draw the line. Okay. Now it is perpendicular and 65 mm height, and it is also perpendicular and 65 mm, and this is okay. And let us also mark the axis line. So axis is going to be the center line here. So it should be a dotted line. Sorry, axis line, long dash, short dash, long dash, short dash. Okay. So these are points A dash comma B dash. These are the points C dash comma D dash, and it is O1 and it is O2. This is 1 dash comma 2 dash, and this is 3 dash comma 4 dash. Now let us draw the top view of the second stage with the help of existing top view and the second stage front view. let us mark the points. Where is A? A is on this line as well as on this line. This is going to be A. This B is on this line. This is B. And where is C? C is on this line. So this is C. And this is D. This is O1. And where is 1? This is 1. This is 4. This is 3. This is 2. Okay. So now let us mark all the points which are outside the boundary line. So A, B are on the extreme left, nothing else on the left side of this. Okay, it should be connected with a straight line, and B to C should be also connected with a straight line. After B to C, I'm going to connect C2 to C to 3. Everything is outside. So from C to 4, 3 to 4, and 4 to 1, 1 to D, A to D. So whatever the points on the boundary line, I have connected them with a dark line, and this is O2. Now let us see whether all the base edges are over or not. So AB is over, BC is over, CD is over, CD is not over. We have to identify whether it is dotted line or continuous line. Let us look at the inclination of this particular CD. So how to guess whether the particular portion is okay? So I already mentioned that you just divide the solid into two pieces. You just divide the solid into two pieces. The portion which is away is 1. The portion which is close to the XY line is right. The portion which is away from the XY line, okay, is going to be visible or continuous line. The portion which is related to the section 2, which is close to the XY line, is going to be related to the dotted lines. Now let us check. AB is over. Let us see CD. CD comes under the portion hidden. So this should be joined by dotted line. So boundary line is not related to the portion 1 and portion. If it is comes under the boundary line, whether the edges comes under the section 1 or section 2 is continuously a dark. Okay, the boundary line is having a separate rule. Okay, other than this, when you are checking, then you have to check. So let's see. Now A to B is completed, B to C, C to D, D to E is over. Then 2 to 3, 3 to 4, 4 to 1 is there, but 1 to 2 is not mentioned. But 1 to 2 is there, where 1 to 2 is in the visible zone. So 1 to 2 should be joined with a continuous line. Okay, the second stage top is over. Now in the third stage, so edge inclination. Edge inclination, I have to represent the edge of on its base on the HP and inclined at 30 degrees to the VP. Let's draw a line at an angle of 30 degree. Okay, so on this line, let us mark the edge. So what is the edge I kept on the right side? This is the edge CD. Okay, the CD should be here. The CD should be on this line. So let us say this is C, this is D. So from this point, extend a vertical line. From this point also extend a vertical line. So no, this is C, this is D. Okay, so this is point A, this is point B. On the line of BC, we have 3 at this distance from C. On the other side, we have this point. This is point 3. This is point 4. Okay, connect from here to here. And we have a dotted line CD. So by mistake I made it dark, it should be a dotted line. What is the other line? Just take the distance from 3 to 2 and 4 to. And in between 3 and C, 3 and C, this is point 2 and this is point 1. Okay, the same top view I have drawn once again in such a way the edge CD on the right side edge, okay, the right side edge CD is going to be mentioned on 30-degree line. Okay, and the top is going to be flipped by 30 degree. Now let us see the respective front view. So extend each and every point to the top. Center line. Now let us mark each and every point from starting from A. A is on this line. So where is A? A is here. This is point A dash. So this is point A dash. Now where is the point B? B is on this line, and this is point B dash. And where is the point C? C is on this line, and where is C here? We didn't extend any line from C. This is point C. And point D. This is point D. So A to B, B to C, C to D. Okay, next let us mark 1, 2, 3, 4. 1 is on this line. This is 1 dash. 2 is on this line. This is, so now this is 2 dash, where is 3? 3 is on this line, this is 3 dash. Where is 4? 4, this is 4 dash. Okay, so 1 2 3 4 and A B C D. In between, let us locate the centers O1 and O2. Let us say this is O2, this is O1. So here it is O2. And where is O1? So let us mark the lines and the boundary lines with a continuous line. Now see, the C3 is an extreme left, nothing comes under. Okay, so it is going to be extreme left. So now we have to join 2 to 3, which is comes under extreme boundary line, and we have 1 here. This is also comes under extreme boundary line, and from 1 to 4 or 1 to A. Instead of 1 to 4, 1 to A comes under the boundary line. So I'm joining this one, 1 to A. Then A to B or A to D. So this A to D is going to be comes under boundary line, and this C to D comes under the boundary line. Okay. So some portion is over. Now let us check. So where is the axis line? Axis line is here. So I'm going to divide the total solid into 2 pieces. Now this is a segment 1, this is a segment 2. The segment which is close to the XY line is going to have the dotted line in this. The segment which is away from this XY line, the segment 1 is going to have the dark lines. Let us check all the bottom lines. A to B is whether A to B comes under this segment or this segment. A to B I cannot guess, because some portion is comes under dotted and some portion is comes under visible. Let us see BC. A to B is in withheld. So BC, let us see BC. So BC is comes under dotted line zone. So B tissue is going to be connected with a dotted line. Now, so C to D is over. Now let us check 1 to 2 is over, 2 to 3 is over, 3 to 4. So even 3 to 4 also, some portion is comes under visible zone, some portion is comes under dotted zone. Other than that, 3 4 4 1. What about 4 1? 4 1 is in the visible zone. So 4 1 should be a dark line. Okay. Now see, there are some points within the boundary line. There is a point B, there is a point 4. So if any point is there within the boundary line, from that point either 3 dotted lines will go or 3 continuous lines will go. Okay. So within the boundary line, whatever the points are there, from those points either 3 dotted lines will go, otherwise 3 continuous line. So from B to C already a dotted line, then B to A should be also a dotted line, and B to 2 also a dotted line. Now here 4 is there. As for 4 to 1 is already continuous line, and 4 is within the boundary line. From 4, whatever the lines are possible, they must be continuous lines. That's it. Okay. So whether the figure is right or wrong, how you can check? So whenever two lines are intersecting, out of these two, one should be continuous and the other should be dotted line. See, this is the dotted line intersected by the continuous line, and this is the dotted line intersected by the continuous line. So in any projections of solids, two continuous lines should not intersect each other, or two dotted lines should not intersect each other. They may coincide, but they should not intersect. So with this, let us stop.